In this video, we are going to discuss about Astable multivibrator using IC555. So this is a connection diagram of Astable multivibrator. So here you don't have any trigger pulse. Okay, without any trigger pulse, it is going to generate a rectangular waveform. Okay, so you can see the seventh pin is discharge pin, which is connected to the junction of RA and RB. Okay, so here the threshold and the control voltage, trigger pin, right? The threshold, and you can see what is the sixth and the second pin. Sixth and the second pin is a threshold and trigger pin. Okay, that is connected to the VC value. Okay, VC. Okay, so let me assume initially the capacitor voltage is below um, 1/3 of VCC. Okay, because it is very less value, right? So if it is below VCC, let me assume the VCC value is 3, means now it is below 1 volt, right? This is below 1 volt. So if that is the case, you can see since this value is greater than the second pin, okay, and both these pins 6 and 2 are short circuited. Okay, so this becomes 1 initially, and this becomes 0, right? Okay, so my output goes to 1, right? My output goes to 1, so this will go to 0. So if this is 0, means the discharge pin is open circuited. Okay, okay, so this is the first case. Okay, so and you can see since this discharge pin is open circuited, okay, and my output is 1, right? My output is 1 initially. Okay, so what will happen, and now so this the capacitance will start to charge through this path, right? So if it started to charge, means okay, so you can see my output voltage is VCC initially, and my capacitance is less than 1.3, right? 1/3. So now the capacitance started to charge. Let me assume it is 1/3 VCC. So if it is 1/3 VCC also, though it is in 1/3 VCC, here also it is this is 1 only. Okay, if it is go above the 1/3 value, okay, so suppose if it is going above 1/3 value, then this will go to 0, right? This will go to 0, and this will also 0, right? So it will remain in the same state, right? So my capacitance it started to charge, right? It will started to charge, and it will reach its value called 2/3 VCC. Okay, 2/3 VCC, right? So if it reaches 2/3 VCC during this stage, since this is 2/3 VCC, it is going to 0. So if it goes above the 2/3 value, or it will go to 1, right? So it will go to 1. Therefore my Q will go to 0, and this one will go to 1, right? Since Q is 1, the discharge pin, it will start to discharge through this transistor, and it will reach the ground. Okay, so whenever it reaches the 2 by 3 value, my output goes to 0, right? My output goes to 0, and the discharge pin get activated. So if the discharge pin get activated means, what will happen? The capacitance started to discharge, right? So the capacitance started to discharge through this path. Okay, through this path, it will started to discharge. Okay, so my capacitance, it will started to discharge, right? So whenever it tends to go below this 1 by 3 VCC, it will again go to VCC, right? So again the capacitance will start to charge. So now again the capacitance will start to discharge. So this process will goes on. So you know that the charging of the capacitance takes more time compared to discharging. Okay, so you can see, if you see, the capacitance is so what I'm telling you is, if this is T1, okay, if this is T1 and if this is T2, so during this time the capacitance is charging, and it will discharge very fastly. Okay, it will discharge very fast. Okay, so if that is the case, you will get the pulse width of the T2 is very small compared to T1. Okay, so this is a V0 output you will get. Okay, so first let me write T2 is a time taken by the capacitor to charge from 0 to 1 by 3 VCC. Okay, so if the time it takes from 0 to 1 by 3 is, I can write VC of t is equal to VCC into 1 minus e power minus t T2 divided by RC. Okay, so the final value it reaches is VC 1 divided by 3 VCC into 1 minus e power minus T2 divided by RC. Okay, so if I solve, I'll get 1 by 3 is equal to 1 minus e power minus T2 divided by RC, right? So e power minus T2 divided by RC is equal to 2 by 3. So if I take ln on both sides, I will get minus T2 divided by RC is equal to 2 by 3 ln of 2 by 3. So my T2 is equal to RC ln of 3 by 2. That is equal to 0.405. Okay. Next, time taken by the T1 is the time taken by the capacitance to charge from 0 to 2 by 3 of VCC. Okay, so if that is the case, I can write the final value to reach is 2 by 3 VCC, that is equal to VCC into 1 minus e power minus T1 divided by RC. So if we solve, you will get 2 by 3 is equal to 1 minus e power minus t1 divided by rc. So e power minus t1 divided by rc is equal to 1 by 3. So minus t1 divided by rc is equal to ln of 1 by 3. So you will get t1 is equal to rc ln of 3, that is equal to 1.098 rc. Okay. So since I want only the capacitance, the T1 is the time taken by the capacitance to charge from um, 1 by 3 VCC to 2 by 3 VCC. So T1 is equal to T1 minus T2. So that is equal to 0.693 RC. Okay. So if I solve that one, I will get T on, you know that the capacitance, it will charge through this resistance RA and RB, and it will discharge through RB, right? So we know that T is equal to T on plus T off. Okay, so that is equal to 0.693 RA plus 2 RB into C. So we know that the frequency is equal to F is equal to 1 by T, that is equal to 1.45 divided by RA plus R into 2 C. Okay. So we know that the duty cycle is equal to T on divided by T on plus T off into 100. It is represented in percentage. Okay. So if I solve, I will get RA plus RB divided by RA plus 2RB into 100. T of is equal to time taken for the capacitor to discharge from 2 by 3 VCC to 1 by 3 VCC. So let me take that is this one. This is nothing but T of. Okay. So I can write Vc of t. Vc of t is equal to V final plus V initial minus V final into e power minus t divided by Rc. So what is my final value? I am going to get the final value I am going to get is 0. Okay, 0. So this is my final value. Okay. What is my initial value? Initial value is 2 by 3 VCC. This is my initial value. So 2 by 3 VCC. But the final value it is reaching is it is about to reach is 0, right? So instead of t, I am going to write t of. Okay, t of, and instead of r, I am going to write rb into c. Okay. So what is the value it is reaching by the Vc of t? Vc of t, it is reaching only 1 by 3 of VCC. So, okay. So if I solve, I will get these two get cancelled out. 3 also gets solved. So I will get 1 by 2 is equal to e power minus t of divided by Rc. So if we take ln on both sides, I will get ln 1 by 2 power minus 1, that is equal to t of divided by Rb into C. Right. So what is t of now? T of is equal to RBC into ln 2. So ln 2 is nothing but 0.693 RB into C. Okay. So next let us discuss one problem based on the university exam. So they have given the question is they are asked to design the Astable multivibrator using IC 555, and they are given C value is equal to 0.1 microfarad, and frequency they are going to get this. We are supposed to get this 150 hertz. Okay, and duty cycle is equal to 70%. Okay. So how to solve this one? So we know that T on. What is T on? T on is equal to 0.693 RA plus RB, right? T on divided by T on plus TF, that is nothing but 70 they are given. Okay, so this I can also write it as RA. How to write this one? This is nothing but T on is nothing but 0.693 RA plus RB into C, right? So this is nothing but RA plus 2RB into C. Okay, so this will get solved. So this is nothing but 70, right? This is equal to 70, and this is my duty cycle, right? Okay, so what is F? F is nothing but 1.47 divided by RA plus 2RB into C. Okay, so if you solve this one, you will get what is the value of RA plus 2RB, right? RA plus 2RB is equal to 1.47 divided by 150 into 0.1 microfarad, right? So if you solve, you will get RA plus 2RB, right? So if you solve, once you get the value, you substitute here. So you will get RA plus RB is equal to 70 into RA plus 2RB value, right? So it is in terms of percentage, so we will get 0.7 into something. Okay, so from this